Hey, I'm Isaac Lawrence, and I'm a master's student in the Rubenstein School of Natural Resources, and I'm also a graduate researcher at the Transportation Research Center at UVM. My project today is a model to predict impervious surface impacts of land use and transportation system change within UrbanSim. UrbanSim is an integrated land use and transportation model, the point of which is to allow planners and researchers to predict what sort of land use change and transportation system change is going to take place as a result of different policies, different built infrastructure, changes in the economy, etc. So what I was working with here is to create an indicator within the UrbanSim framework that predicts how much impervious surface area is going to be associated with any of the things I mentioned: new development, change in infrastructure, change in the economy, etc. So this is just a preliminary analysis because our 2005 base year of the UrbanSim model isn't complete, but I took some variables that I had available, including residential units, distance to the airport, percent roads, which is something we calculated, number of employees, percent tree canopy, and a couple others. And I just ran a simple linear regression on the percent imperviousness from 2005 using those variables. And then I aggregated my results up to a town level and then a 1,500 meter grid cell level. UrbanSim's at a 150 meter grid cell level analysis, so that's just 10 times the grid cell size. And I got some fairly exciting preliminary results. When aggregated, my most complex of the models using residential units, employment, percent roads, and distance to the airport. Once I aggregated up my results from that, I got an R-squared value of 0.86, which is pretty strong. So my next steps just include re-estimating the model with the new variables we have available when we're done estimating the 2005 base year, and then additionally trying to build this from an indicator into a model that runs iteratively, so we can adjust, say, a coefficient associated with development, so we could say that new development might have less impervious impacts than previous development of the same kind. So we could introduce that to the model. But that's about it.